Okay, welcome back. Today we're going to talk about different types of numbers. Right. So the numbers that you've been working with so far, I've represented a lot of them on this page right here. So let's look at the type of numbers that we've seen so far. We've seen this is a negative number with a repeating decimal. This is a number with a repeating decimal that I represent with bar notation. This is a terminating decimal. This is a mixed number, so a whole number and a fraction. And then we have another rational number, or we have another fraction right here. Zero, so we have whole numbers here. We have negative numbers. And we have these numbers, the square roots of imperfect squares. So if I were to try to sort these numbers, the first thing that I'd probably try to do is try to put everything, maybe all the whole numbers together, like this. Right? It's going to be a little difficult for you to take notes with this, so why don't you hang on for a minute and we'll take some notes a little bit later on. You're going to have some interactive notebook things that you're going to do for this section, so just hold off taking notes. I'll let you know when you're supposed to take notes. Okay, so we have these whole numbers here, and I could probably classify further the whole numbers into numbers that actually have value, 0, and then we'll put the negative numbers up here. And we have fractions here, and then we have decimals, right? So we have fractions here, we have decimals, this is decimals that repeat here. And then we have these weird numbers over here like pi, the square root of 2, and the square root of 42. Okay, so just naturally, if I were, just given a bunch of numbers and I were asked to sort them, I'd probably sort them this way. And so it comes as no surprise that mathematicians have also have categories of numbers based on the properties that they have. So here I have two sets of numbers here, and let me pull the screen down just a little bit so you can see it. I have two Venn diagrams here. They both say the same thing. This top Venn diagram just uses rectangles to show the relationship between categories of numbers, and the bottom one uses ovals. Okay, so it's the exact same thing. It's just these ones have examples of the numbers as they're classified. These ones do not, and one uses ovals and one uses rectangles. Okay, so what I would like you to copy down in your notes is this top chart up here, this real number chart. And we're going to make other charts in your notebooks a little bit later with the interactive things that we're going to add to your notebook. But for right now, let's talk about the classification of numbers. And one thing I want to clarify is 2 to the 1/2 as an exponent is the square root of 2. Okay, so these numbers, all the numbers that we've been dealing with are numbers called real numbers. Now, real numbers are sorted into two parts, rational numbers or irrational numbers. Now, the only way to understand irrational numbers is to first go over what rational numbers are, because irrational numbers are going to be compared to this other set of numbers called rational numbers. Now, let's start by working our way from the smallest rectangle, the smallest set of numbers, the natural numbers. Let's work our way from the natural numbers out. Okay, so the natural numbers are the first numbers you began working with. They were the numbers that your teacher probably started to give you when you were in elementary school. They're also called counting numbers, the numbers that you would use to count objects, right? Beginning at 1, 2, 3, 4, and so on. Okay, so that's in this this rectangle right here. Now, after the natural numbers, we added 0. And now the natural numbers plus the addition of 0 are numbers called whole numbers. This is identified in the set. Remember how we use Venn diagrams? The beige rectangle is entirely within the pink rectangle. So the pink rectangle contains the beige rectangle. So that means everything, the whole numbers are everything in the beige rectangle plus 0. So the whole numbers are the natural numbers plus 0. Okay. Then when you got into middle school, you learned about integers. Now, integers are the opposites of the natural numbers. So now the set of integers are the natural numbers plus 0 plus all the opposites of the natural numbers. Those are the integers. Again, this is shown with Venn diagrams because the beige rectangle and the pink rectangle are entirely within the yellow rectangle. Okay, so the integers are every set before it plus the opposites of the whole numbers. Now, rational numbers are, look at the word rational, it has this prefix ratio. Ratio is any number a over b where a and b are integers, except b cannot be equal to 0. So a and b is a ratio of two integers, so a and b must be integers. So it could be any of the numbers that you see here. You could have negative rational numbers like negative 3/4. You could have improper fractions like 7/8. Oh, sorry, 7/4 is an improper fraction. Okay, so improper fractions, negative fractions, unit fractions, those are fractions with 1 in the numerator here. Any of these things are called ratios. And remember, anything that, any number that terminates or any decimal that terminates or repeats can be turned into a ratio. Okay, so for rational numbers, it's anything that's a ratio of two integers, like we said before. So it can be a over b, where b is not equal to 0, and a and b are integers. Okay, so they're the set of numbers here. So irrational numbers are defined by the rational numbers because what this prefix here, IR, means is it means not. Okay, so irrational numbers are numbers that are not rational. What does it mean to be not rational? Well, the definition of rational means it can be turned into a ratio. So irrational numbers means it cannot be turned into a ratio of two integers. Okay, think about the numbers that, the decimals or the numbers that cannot be turned into ratios. Well, they're not integers, so they have to have decimal expansions. But the decimal expansions, so anything with a decimal that terminates or repeats can be turned into a ratio of two integers. We saw that before in our previous lessons. So decimals that terminate can be turned into fractions. Decimals that repeat can be turned into fractions. So something that can't be turned into a fraction are decimals that neither terminate nor repeat. So let's write that down. Decimals that do not terminate and they do, and do not repeat. Okay, we talked about pi being one of those type of decimals. We talked about the square root of 2 being one of those type of decimals. Okay, so if we go back to the classification here, we've pretty much classified it the way that our intuitive sense of classifying these numbers is about the same thing as what mathematicians have classified it as. So these two numbers are the counting numbers or the natural numbers. This was -9 here. If I add 0, we get to the, let's see, these are called the whole numbers, right? If I add 0 to the natural numbers. Then if I want to add one set of numbers larger than that is the integers. So if I put just -9 there, that would be the integers. And then everything else, all the things that have decimals in them or are represented as fractions that are not reducible to integers, okay, those are called the rational numbers. Those are rational numbers, but they're not integers. So this is basically, I'm just redrawing these Venn diagrams for you, okay? And then everything else is just the irrational numbers, okay? And all together, these sets of numbers, both rectangles, are called the real numbers, like you saw right here, right? So a lot of times we're asked to describe what set of numbers we would use in certain situations. So let's say the amount of pencils in your backpack. Now, if we thought about the amount of pencils in your backpack, well, there's a couple of different ways. It depends on if we allow for parts of pencils. So if we allow for parts of pencils, we could say that we have 2 whole pencils and maybe a half of a pencil, so about 2 1/2. Well, as soon as I allow for fractions that aren't reduced to integers, okay, that means like there are some fractions like 4/2 that are reduced to integers. So I would just call this an integer. But there are other fractions like 1/2 that are not reducible to integers. So here, this is just be a fraction that doesn't reduce to an integer. Well, if we allow for fractional parts of pencils, then the set of numbers that, the smallest set of numbers that we would use to describe pencils in your backpack, so let's go back to our description of numbers here, we would have to go, so let's see, the natural numbers wouldn't just cut it if we allow for parts of pencils. 0 would also be fine, but we wouldn't have any negative numbers here, but there would be fractions that don't reduce to integers. So here I'd have to say rational numbers. Now, if I weren't allowing for parts of pencils, then I would have to say that it would be whole numbers, because I could also have, I could have the counting numbers, but I could also have 0 pencils in my backpack. Okay, so it sort of depends, and I should have been a little bit more descriptive about that, but that's okay. I'll be more descriptive in things that you are graded for. Okay, the amount of rainfall in New York during a year. Well, let's think about how we would describe that. We might use a unit like centimeters, and we might say something like 25.2. It's probably very unlikely, it is very unlikely that we would have just a, if we were to describe rainfall, that it would always be in, there would never be a part to the centimeters. It's usually that it's like 25.2 something or 30.7. It usually has a decimal part of it. So again, we're going to use rational numbers because whole numbers just won't cut it. Now, don't be confused, because rational numbers include integers and we would never have any negative rainfall, but rational numbers also include just parts of numbers and not whole. So if we just look back at our set here, whole numbers are just going to be 0 in the natural numbers, but again, we're going to have parts of a centimeter or parts of an inch that we included in rainfall, so we're going to have to bump up our set of numbers to include numbers that have only parts and not whole. Okay. The amount of people in the United States. Now that's a little different, so let's go back to our set of numbers. We know there's not 0 people in the United States, and we also know that there aren't parts of people, and we also know there's not negative people. So here, the natural numbers is going to be the only set of numbers that we would need in order to describe the amount of people in the United States. Okay, and that's how you would answer questions like that. All right, and that's the end of the lesson for today. Thanks.